going to give you what is a locus. So if I give you a point, right, and I tell you this point P is always equidistant from this unknown. Let's call it unknown R, right? So this point P is always, no matter how it moves, it's always going to be the same distance away from R. Okay? So it might move something like this. Correct? What does it trace out? It will trace out a circle. Right? So what is the locus? The locus is the path that a point will trace out when given certain conditions. That's okay? So if I tell you that this point P is always equidistant from this point, then the path that that point P will trace out is called a locus. Write this down. The locus of a point, the locus of a point is the path the point will trace out when given certain conditions. When given certain conditions. For example, the path traced out, when a point P is always equidistant from a point C, it traces out a circle with center C and radius, whatever that distance was. Let's call it D, right? With a center C and radius D. All right, so before I give you some standard ones, let's start with this one here. What is the locus in this case? P is always 3 units away from 2, 3. You can watch this and then notice a what? You can watch it and then notice a circle with center and radius 3, right? Or we can also prove it. Here's what you can do. Right, here, let's plot 2, 3. Let's say 2, 3 is here. And P is somewhere here. Right? And this distance is always going to be 3. So P is a random point, right? P is a random point, X, Y. Right? So the formula is what? The square root of x2 minus x1 squared plus equal to, I can square both sides. Square both sides. What do we have? We have a circle, right? So we have a circle. We have a circle with center 2, 3, radius 3. Let's see if we can figure out what this one is. P is always the same distance away from. P is always the same distance away from 2, 3, and so it's always the same distance away from 2, 3, and 5, 7. So what's this here? I didn't give you any value for D, right? For distance between them. So we need to find a way to get an equation given this information. So here's what you can do. So from here to here, that distance, let's call it D. All right? Based on the information Shivish, what's the distance from here to here? Same. Is there any way we could get an equation? Right? So could we use these 2 points, this and xy, and find D, and use this and find D, and then do what with them? Equate them. So the first one is what? G is equal to the square root of x minus 2 plus y minus 3 squared. And then if you use here now, square root of, leave the x first up, x minus 5 squared, y minus 7 squared. Try that here. Remember, you'll get an equation, so you're not solving anything. Right? So you're going to square both sides. When you square both sides, you're going to get a square root, right? And then all we have to do is expand this out. We'll get x squared minus 4x plus 4 plus y squared minus 6x, sorry, minus 6y plus 9 is equal to x squared minus 10x plus 25, y squared minus 14y plus 49. You will see immediately that the squares will cancel off. Right? Bring all the x's together now. So you'll get minus 4x plus 10x. You'll get minus 6y plus 14y, and bring all the constants on one side. That's 25 plus 49 minus 4 minus 9. Right? So you'll get 6x plus 8y is how much here? What are this? What is this here? A straight line. A line, right? So this will probably form a line. All right, take a small note on 3 standard Locus that I should do. Number 1, a circle always equidistant from a fixed point. Always equidistant from a fixed point. Ellipse, sum of the distances. Right, for the ellipse, the sum of the distances from 2 fixed points, is always constant. It's always constant. And third one, parabola is always equidistant. The parabola is always equidistant from a fixed point called the focus. From a fixed point called the focus, and a fixed line, called the directrix. Okay, so those are the 3 standard ones that you should know, right? Let's experiment with one of them. How you draw the line x equal to 1 again? Right? Find x as 1 and draw a horizontal line. So, quick question. If you had to guess, what's this point here? Well, you sure is 1, eh? 1 what? 1 y. You sure is 1 y. Right? Or you sure here is? You sure here is what? 1 y. So anywhere on this line is always what? 1 y. Okay? So anywhere on this line is 1 y. So let's say we have a point 1 y and we have a point 4 2. Right? And we have the point P. P is xy, of course. And P is always equidistant from this line and this point. See if we could find that Locus. All right, so let's see what we got. Between here and here, it'll be, right, the square root of x minus 1 squared plus y minus y squared. Right? And that is the same as here to here. That's the square root of x minus 4 squared plus y minus 2 squared. Right? Square both sides, and you'll get x minus 1 squared. This is 0. Is equal to x minus 4 squared plus y minus 2 squared. So this will be x squared minus 2x plus 1 is equal to x squared minus 8x plus 16 plus y squared minus 4y plus 4. Right? X squared will cancel, and you can bring everything on one side. You'll get minus 2x. Actually, try it on that side, right? Minus 8x plus 2x plus 16 minus 1 y squared minus 4y plus 4 equal to 0. So I have y squared minus 4y minus 6x. This is what, 15, 19? Anybody get that? The signs might be different. The signs might be different, right? Start with part B first, and then we do part A. Let's see what you get. Draw a diagram to help you with part B. Yeah? Right, so they give me these 2 points. So one is 0, 3, and the next point is 5, 2. Right? So the point P now moves so that its distance from 0, 3 is 2 times the distance from here. So let's pretend P is somewhere here. P is xy. So they said that the distance from 0, 3, so this distance is twice the distance from here. So if here is D, here is 2D. So it's very, very important that you have the diagram right. So Shivish, what is D? Square root of x minus 5 squared plus y minus 2 squared. And what is 2D? 2D is the square root of x minus 0 squared plus y minus 3 squared. Right. So square both sides, and you will get d squared to be equal to this. And you will get 4d squared to be equal to this. All right. Once you have that now, once you have this, you can substitute equation 1 in equation 2. So I'm going to put 1 in 2. So I'm going to take off d squared, and I'm going to write this. See that, Nikolai? Right? It's equal to this here. X squared plus, expand it one time, right? Y squared minus 6y plus 9. Right? So it's 4y, I'm going to multiply out here. X squared minus 10x plus 25 plus y squared minus 4y plus 4. Right? You can bring everything across one time, I guess. Minus x squared minus y squared minus plus 6y minus 9 is 0. Multiply everything by 4. 4x squared minus x squared is 4 minus 10x is minus 40x. 4 by 25 is 100. 104. 104 minus 9, 95. Then deal with the y squared now. 4y squared minus y squared is positive 3y squared. Minus 16 plus 6 is minus 10y. Deal with the constants already, yeah? Let me make a mistake here. 4. That's 100 plus 16. Yeah. So it's 116 minus 9. Right? Is equal to 0. So this is 3x squared plus 3y squared minus 40x minus 10y plus 107 is that. If you divide everything by 3, you'll get x squared, y squared minus 40 on 3x minus 10 on 3y plus okay, so you'll get something like that. So it's a circle, right? So you can see it's a circle and you can find the center and radius. All right, there was the next one I wanted to do. Try this one here, please. Part C. Ignore the rest around. I'll be able to come back and do the other thing after. Type part C. That's 2060. All right, so the point P moves such that its distance from the x-axis is half the distance from the origin. Right, when you square both sides, you'll get 4d squared is equal to x squared plus y squared. When you square both sides here, you'll get d squared is 0 plus y squared. Right, this equation. Right, do the usual thing, substitute equation 1 in 2, but sorry, 2 in 1. Right, so you'll end up with 4y squared is equal to x squared plus. So again, 4y squared minus y squared is. So you're getting 4y squared is equal to. That's 3y squared. Sorry, 3y squared. Thank you. 3y squared is equal to x squared. There are two circles, right? How do I get the Cartesian equation, Shivish? Shivish, how do I go from parametric to Cartesian? First theta the subject and then what? And substitute into what? Sine squared theta plus cos squared. Get these two Cartesian quickly. Now remember how to identify the parametric. Suppose it didn't say this here. How would you know it's a circle? Right, the value in front here is 3. And what about if the value is different? Yeah. It'll be a what? Ellipse. Nice. Right, do me a favor. Just find the Cartesians there and then we'll just talk about how to solve them. From here, we have cos theta is equal to x plus 3 on root 10. Here we have sine theta is equal to y minus 2 on root 10. Square both sides and make it equal to 1. I remember cos theta plus sine squared theta is 1, right? Square both sides and multiply everything by 10. And you'll get x plus 3 squared plus y minus 2 squared is 10. I just squared both sides and multiplied by 10. Next is x minus 3 squared, right? Y minus 2 squared and multiply by 16. All right, before the getting lost, right? This is all I'm doing, right? Cos theta is equal to x minus 3 and 4 after square that. Right? And then you will get the sine theta. That'll be y minus 2 and 4 square that. And then you have to add them and make it equal to 1. When you square the 4, you'll get 16. So you multiply everything by 16 together. Right? And then to get the point of intersection, how are we doing it? Substitute each other. substitute one to the next and solve simultaneously. But wait. Before you do it, something you have to do. Whenever you have two circles, right, and you have to solve simultaneously, you have to subtract the two circles first and get a line. Then use that to make x or y subject to the formula. Right, so subtract C1 and C2, write it down. Subtract C1 and C2, and then make y the subject on the line and finish it up over.